Welcome to All Things Electronics. Even though we usually talk about everyday tech, firearms also belong here because they are engineered systems, built around controlled energy, materials science, springs, timing, and precise mechanical logic, much like many classic electronic devices. Today's episode looks at famous firearms as design systems, not instructions. When people say a firearm is easy, they are really talking about good system design. In electronics, we value devices that behave the same way every time, give clear feedback, and do not overload the user with controls. The Glock 17, designed in the early 1980s by Austrian engineer Gaston Glock, follows that exact thinking. Glock came from an industrial manufacturing background, not traditional gun making, so he treated the pistol like a product platform. The design uses a polymer frame to reduce weight, steel inserts only where strength is needed, and a very small number of internal parts. From a systems point of view, this is like simplifying a circuit by removing unnecessary components. The internal safety logic works automatically, meaning the user does not have to manage switches during normal handling. This predictability is why it spread globally. Legally, ownership depends entirely on local law and usually involves licensing, background checks, training requirements, and strict storage rules. The Glock 19 uses the same internal architecture but in a more compact physical package. In electronics terms, it is the same device in a smaller enclosure, with identical software logic inside. The springs, internal safeties, and operating cycle behave the same way, which is why learning transfers easily between models. The slightly shorter grip and slide change the physical feel, but not the system behavior. That consistency is a major reason it is considered approachable from a design perspective. Legal requirements are the same as other Glock pistols and vary by country. The Smith & Wesson MNP9, released in the mid-2000s, reflects a design philosophy focused on human comfort and interface design. Smith & Wesson, founded in 1852, studied how hands interact with objects, much like designers study how people hold phones or controllers. The grip shape, surface texture, and balance were engineered to reduce strain and improve control. Internally, the system uses a striker mechanism with passive safeties that function automatically, similar to background processes in a device that protect operation without user input. This combination of ergonomics and predictable behavior made it popular with organizations worldwide. Legal ownership typically requires permits, proof of training, and compliance with storage and transport laws. The Beretta 92 FS, produced by Beretta, founded in 1526, shows classic mechanical engineering values. Its all-metal frame adds mass, which helps absorb and smooth out energy, similar to how heavier components reduce vibration in machines. The exposed hammer and visible safety systems give clear physical feedback, like tactile switches on older electronic equipment. This transparency made it trusted for military service in the 1980s. From a systems view, it favors clarity and robustness over compactness. Civilian ownership laws vary widely and are often strict due to its military background. The CZ-75, introduced in 1975, became iconic because of how its internal parts are arranged. Its slide runs inside the frame rails rather than outside, lowering the moving mass and reducing wobble. In engineering terms, this is like improving alignment in a moving assembly to reduce friction and noise. The steel frame adds stability, and the grip angle naturally aligns the hand, which improves control without extra effort. These design choices made it feel smooth and predictable. Legal treatment depends on the country but usually follows standard handgun regulations. Rifles bring us to the AK-47 and AKM, designed by Mikhail Kalashnikov and adopted in 1947. From an engineering standpoint, the AK is a masterclass in fault-tolerant design. Parts are made with generous clearances so they continue moving even when dirty or worn. This is similar to industrial electronics designed to keep running despite heat, dust, or power fluctuation. The materials are strong but simple, and the system avoids tight tolerances that could cause failure. While this rugged design made it globally iconic, civilian ownership is heavily restricted or banned in many regions. The AR-15, created by Eugene Stoner in the late 1950s, represents a more modern engineering mindset. It uses lightweight alloys and a straight-line layout that channels energy efficiently. From a systems view, its biggest strength is modularity. Components can be swapped much like parts in a computer. Stocks, grips, and upper assemblies connect through standardized interfaces. This flexibility made it widespread and recognizable. However, legal access varies dramatically by country and even by region within countries. The SKS, developed by Sergei Semenov near the end of World War II, reflects an earlier generation of system design. Its fixed magazine reduces moving interfaces and limits complexity, similar to early electronics that favored fewer connectors and components. The design is stable and deliberate, encouraging controlled operation rather than speed. In some countries, its historical classification affects how it is regulated, sometimes making it easier to own than newer designs. Shotguns highlight manual system control, starting with the Remington 870, introduced in 1950. Instead of relying on automatic cycling, it uses human input to manage the system. From an engineering point of view, this removes dependency on energy timing and makes performance consistent across different conditions. The internal layout is straightforward, durable, and easy to maintain, which is why it became so widely trusted. Legally, pump-action shotguns are often treated more leniently than other firearm types, though permits and safe storage are still required. The Mossberg 500, released in 1960, builds on this concept but improves interface design. The top-mounted safety is easy to see and reach, regardless of hand dominance. This focus on visibility and accessibility mirrors good electronic interface design. Internally, the system emphasizes durability over complexity, which helped it remain relevant for decades. Legal treatment is usually similar to other pump-action shotguns. Across all these examples, the key takeaway is that ease comes from thoughtful engineering, not from removing responsibility. Just like electronics, these systems must be understood within legal limits, used responsibly, maintained properly, and stored safely. Good design makes systems predictable and understandable, but responsibility always stays with the user.